In this video we have the integral of 1 over the square root of minus x squared minus 4x. What method do we use? Is it trig substitution, u substitution? Let me remind you of some formulas that we have. So these are integrals involving inverse trigonometric functions. So this tells me that if I have anything of the form du over the square root of a squared minus u squared, the formula is going to be arcsine of u over a. Now the a here is a constant. U, of course, is the variable. It could be that u is a function of x. So instead of this u, it could be something like 3x or x plus 2. But if you can get it in that form, then there's your formula. Then several with the second formula, du over a squared plus u squared is equal to 1 over a. Arctangent, that's again tangent inverse, u over a plus c. And then you have the third one. It gives you 1 over a arcsecant of absolute u over a plus a constant. Now the one that we have in this video appears to be formula 1 here, the first one, involving the arcsine. So I got to write it as the square of something, constant minus u squared. So I'm going to take the radicand here, minus x squared minus 4x and I'm going to factor out a negative here. So it'll be a minus here, x squared minus 4x. And put parentheses here. I'm going to see if I can complete the square on this one. But if I put a 4 here, that's a perfect square. That would be x minus 2 quantity squared. X minus 2 times x minus 2 gives us x squared minus 4x plus 4. But if I put a 4, now I'm multiplying that 4 by a minus. So I'm actually adding a minus 4. So in order for this to work, I can't change the problem. I can always add a 0. That's one of the tricks in mathematics. You can always add 0 to an expression. You don't change it. Minus here, that's a minus 4 and a plus 4. That's 0. And then this can be factored here into x minus 2 quantity squared. Then I put the 4 in front. So now this would look, this has the form of the formula we looked at, a squared minus u squared. And this is a plus here. So this would give me a minus x squared minus 4x, and then a minus 4 and a plus 4 gives me the same thing back. So we can make this a plus here. Now, from there, I can just let u equal to x plus 2. Then du would equal to the derivative of x plus 2 is 1, and you multiply that by dx, and I would get that. Now we convert this integral into one involving u. We're going to use one of those formulas that we just went over, the one involving inverse sine. So this should be the integral dx right here. It's the same thing as du, so this would be your du. That's over. And then it would be the square root, and then for this radicand here, that would be 4 minus And of course the x plus 2 is your u. This will be u squared here. Now, using this substitution, we have the integral in the form du over the square root of 4 minus u squared. So this is the same thing as 4, the same thing as 2 squared. So in that formula we just looked at, a would be 2. Then I can go directly to the formula now. If I have it in this format here, the formula said it's always going to be arcsine. So it's arcsine. You could call it sine inverse if you want, of u over a. So in our case, if we go to the u, our u is x plus 2. Remember, we have to give the answer in terms of the original variable. So it's x plus 2, that's u. And the a, 2 squared, it would be a squared, so the a would be 2. So the answer then, final answer would be arcsine, or again, you can say sine inverse of x plus 2 over 2 plus the constant of integration. And that's your answer. Thanks for watching. We'll see you next time.